In this video, we will solve percent problems using a model. A craft store had a total of 50 customers on Saturday. 14% of the customers used a coupon on their purchase. How many customers did not use a coupon on their purchase? First, we need to draw a model. I know that the craft store had 50 customers. So I will draw a bar that represents the 50 customers. And we know the total number of customers was 50, so this represents 100% of the customers. The problem also tells me that 14% of the customers used a coupon. So I'm going to draw a second bar that's equal to the first one that shows me that 14% of the customers used a coupon. So I'm going to mark this part as 14%, and I'll just note in here that they used coupon just so I can remember. Which tells me that this part represents the customers who did not use a coupon. Now, to find the percent of this part of the bar, I know that percent is always out of 100. So if I take 100 and subtract 14, because that represents the customers who did use a coupon, I get 86. So I know that 86% of the customers did not use a coupon. Now that I have my diagram set up, I can use a proportion to solve the problem. And remember, our proportion is percent over 100 equals is over of. And is represents the part of the total, and of represents the total. So the percent, since the question says how many customers did not use a coupon, I know that I want to use the 86%. So I'll put 86 over 100, and I know 50 is the total number of customers, and that's going to be my of. What I'm looking for is my part, so I will represent that with the variable x. To solve my proportion, I will cross multiply. 86 times 50 is 4,300, and 100 times x is 100x, and I need to isolate the variable, which means getting x by itself using inverse operations. So I divide by 100. 4,300 divided by 100 is 43, which equals x. That tells me that 43 customers did not use a coupon. A plumber has a pipe that is 70 centimeters long. He cuts off 20% from the end of the pipe. Then he cuts the remaining pipe into 4 equal pieces. What is the length of each piece? First, I will draw a model to represent the problem. The first bar that I will draw will represent the entire pipe. And we know that that pipe is 70 centimeters long. And again, we'll label it with 100% since it represents the entire pipe. Now I will draw a second bar that's equal to the first bar. And I'm going to show that the plumber cut off 20% of the pipe. And I'm going to label that the part that he cut off so that I can remember. So if this section is 20%, we need to find the percent of the remaining section. And again, since percent is out of 100, I can do 100 minus 20, which gives me 80. So this piece represents 80% of the original pipe. And finally, the problem tells me that he took the remaining pipe and cut it into 4 equal pieces. So I'm going to show that this is cut into 4 pieces here. And what I need to determine is how many centimeters each of these pieces are. Now I will set up a proportion to solve the problem. And remember, the proportion is percent over 100 equals is over of. Is represents the part of the total, and of represents the total. Now, since I'm working with this piece here, I know the percent I'm going to use is 80. So 80 over 100 equals is over of. The total that I'm given is the total of the pipe, so I'm going to put 70 for the total and represent the part with a variable. Now I will cross multiply to solve the proportion. 80 times 70 is 5,600, and then 100 times x is 100x. And now I divide by 100 to isolate that x. And 5,600 divided by 100 is 56. And what that tells me is that this whole piece here is 56 centimeters long. Remember though that the problem says that the plumber then cut the remaining pipe, which is 56 centimeters, into 4 equal pieces. So I have to take the length of the pipe, which is 56, and divide it by 4. And when I do the math, I see that each piece is 14 centimeters long.